All right, if you're a software developer, you've almost certainly uttered the famous last words, but it works on my machine. Well, today, we're going to dive into Docker, the technology that's all about making that frustrating phrase a thing of the past.
You know this feeling, right? You've spent weeks building this incredible new app. It runs like a dream on your computer. But then, the moment you try to run it on a test server or maybe a coworker's laptop, it just completely falls apart.
And that's when you hear it, that phrase echoing in Slack channels and offices all over the world. It's the universal signal that something, somewhere, in the environment is different. But what is it exactly?
Well, it almost always comes down to a few usual suspects. Maybe some files just got missed when you deployed it. Or, and this is a huge one, the new machine is running a different version of some key software. You know, your app needs Node version 14, but the server is stuck on version 9. It could even be a tiny little difference in a configuration file. The point is, these small differences create big problems.
So how do we fix all this chaos? This is precisely the problem Docker was created to solve. It's a platform built from the ground up to bring consistency and predictability to the wild world of software environments.
At its core, Docker is all about building, running, and shipping your apps in a way that guarantees they act the same no matter where they are. The whole point is simple. If it works on your machine, it should work on any machine that has Docker.
And here's the big idea. Docker lets you package up your application, along with all its dependencies. We're talking the right version of Node, specific libraries, the whole shebang, into one neat little bundle called an image. Then you can take that image and run it pretty much anywhere.
And the perks go way beyond just fixing deployment issues. Think about it. A new developer can join your team and get the entire app up and running with a single command. No more spending a whole day just setting up their machine. You can run two different apps that need totally conflicting software versions right next to each other. No problem. And when you're done, you can just remove the app and all its stuff in one clean sweep, keeping your machine nice and tidy.
So, how does Docker pull off this magic trick? Well, the secret lies in a concept called containers. And to really get what they're about, it helps to compare them to something you might already know: virtual machines, or VMs. So a container is basically an isolated little bubble for your application to live in. But here's the game-changing difference. Instead of creating a whole new virtual computer, all the containers on a machine share the operating system of the computer they're running on. They're really just special, isolated processes.
Okay, let's really put them side by side. A virtual machine needs a full, separate operating system for every single VM you run. That makes them huge. We're talking gigabytes, and they can take minutes to boot up. Containers, on the other hand, just share the host OS. This makes them incredibly lightweight, measured in megabytes, and they start up in seconds, sometimes even less.
And that efficiency, it translates into some serious scale. Because they're so light, you can run hundreds of containers on a single machine. On that same computer, you'd probably only be able to run a handful of resource-hungry VMs. It is a massive, massive difference.
Okay, so we know what containers are and why they're so ridiculously efficient. But how do you actually use them? Let's walk through the day-to-day Docker workflow, from the code on your laptop all the way to the cloud. You know, it really just boils down to a simple three-step dance. First, you write a set of instructions called a Dockerfile. Second, you use that file to build your image. And third, you run that image as a container. That's it.
The Dockerfile is your blueprint. It's just a plain text file where you list out step by step everything needed to set up your app. It looks something like, hey Docker, start with a basic Linux system, then install Node version 14, now copy my app files into it, and finally, here's the command to start everything up.
So, when you run the build command, Docker reads that blueprint, your Docker file, and creates an image. This image is that portable, all-in-one package we were talking about. It's got a tiny operating system, the right runtime, your code, all the libraries, everything is locked in and ready to go.
And finally, you have the container. A container is simply a live running instance of an image. When you tell Docker to run your image, it just spins up one of these lightweight, isolated processes. You can start them, stop them, and make as many copies as you want from that one single image.
So, putting it all together, the journey looks like this. You code your app and write your Docker file. You build that into an image right on your machine and run a container to make sure it works. Once you're happy, you push that image to a central storage place called a registry. Then, on any server, anywhere in the world, you just pull that exact same image down and run it. Total consistency, from your laptop to production.
And that central place I mentioned, that brings us to Docker Hub. The analogy here is perfect.
Just like GitHub is where you store and share your code with Git, Docker Hub is the public registry for storing and sharing your Docker images with the world.
So really, here's the bottom line. Docker lets you throw away those long, fragile, step-by-step deployment documents. All of those instructions are now code, right inside the Dockerfile, giving you a perfect, repeatable build every single time. Ultimately, Docker frees you from worrying about all that environmental nonsense and lets you focus on what you actually love doing, building amazing software. Which really just leaves one final thought. What will you build now that you can be sure it'll just work everywhere?